Hey guys, welcome back, I'm Jay. In this episode, we're going to look at elastic load balancing and EC2 auto scaling. Elastic load balancing or ELB automatically distributes incoming application traffic to multiple EC2 instances to prevent traffic overload on a single instance. ELB can send traffic either in a single availability zone or across multiple availability zones for high availability. In the event of an instance failure, or even an availability zone outage, ELB automatically stops sending traffic to that instance or the entire availability zone. There are three types of elastic load balancing. Application Load Balancer or ALB operates at level 7 of the OSI model, which is the application layer. Network Load Balancer or NLB operates at layer 4 of the OSI model, which is the transport layer. Classic Load Balancer is the previous generation load balancer which operates at both layer 4 and layer 7. AWS encourages you to use either Application Load Balancer or Network Load Balancer. With ELB, you only pay for the running hours and Load Balancer capacity units or LCU hours. ELB offers free tier for the first 12 months. You have 750 free hours per month for ALBs or classic load balancers, and 15 free LCUs for ALBs, 15 GB free data processing of classic load balancers. Open Systems Interconnection or OSI model is a conceptual model, which guides vendors and developers and facilitates clear functions of networking in digital communication products. There are 7 layers in OSI model. Layer 7 is the application layer that enables end-user communication for applications, such as web apps and mobile apps. It supports HTTP and many other protocols. Layer 6 is the presentation layer that translates data for the application layer, based on the syntax of application, and handles encryption and decryption for the application layer. Layer 5 is the session layer that coordinates conversations between applications, and handles authentication and reconnection after interruption. Layer 4 is the transport layer that transfers data across a network and controls the data flow. It supports TCP, UDP and TLS traffic. Layer 3 is the network layer that moves data through other networks. Layer 2 is the data link layer that moves data into and out of a physical link in a network. Layer 1 is the physical layer that transports data using electrical signals. Application Load Balancer or ALB operates at layer 7. It's best suited for the load balancing of HTTP and HTTPS traffic. ALB provides the advanced request routing, targeted at the delivery of modern application architectures, including microservices and containers. Network Load Balancer or NLB operates at layer 4. It's best suited for load balancing of TCP, UDP and TLS traffic, where extreme performance is required. It's capable of handling millions of requests per second with ultra-low latencies. Classic Load Balancer operates at both layer 4 and layer 7. It provides basic load balancing for EC2 instance. Classic Load Balancer is the previous generation load balancer. It's intended for applications that were built within the EC2 Classic network, which has been replaced by Amazon VPC. So why do you need load balancing? Suppose you have an e-commerce website running on EC2. Initially you only need one instance to serve traffic from a few users. Later on, when your website gets popular, your instance needs to handle more traffic from new users. A single instance won't be able to respond to the significant traffic increase. Any sudden surge might consume all of the resources of your instance. New requests might be throttled due to limited capacity. If your instance or the entire availability zone fails, your application will lose the availability due to the single point of failure. You have to launch another instance and redirect the traffic. With a single instance, it might take a long time to recover, as the new instance might need time to start the OS and bootstrap. Your users might experience significant amount of downtime. So how do we avoid the single point of failure? We can avoid a single point of failure by using elastic load balancing. Here's an example of the application load balancer. You have a few EC2 instances behind an application load balancer ready to serve the traffic. When the demand increases, the application load balancer automatically distributes traffic across all EC2 instances. It sends an equal amount of traffic to avoid a single instance being overwhelmed. In the event of an instance failure or the availability zone outage, ELB immediately detects the failure and stops sending traffic to the failed instance, and redirects traffic to healthy instances. ELB has the built-in high availability feature across multiple availability zones. Under the ELB, there are many load balancing servers managed by AWS to provide high availability. ELB guarantees to provide at least 99.99% availability. EC2 Auto Scaling helps you maintain application availability, and allows you to automatically add or remove EC2 instances based on the scaling policy you define. For example, it can automatically scale instances based on the CPU utilization, network, and HTTP requests. You need the following components to use EC2 Auto Scaling. A launch configuration or launch template is needed, as a configuration template of EC2 instances. Launch configuration provides basic information for auto scaling, such as the AMI ID, the instance type, a key pair, security groups, and EBS volumes. Launch template provides some advanced features for auto scaling. For example, you can create multiple versions of a template. EC2 instances are organized into an auto scaling group, so that they can be treated as a logical unit for management and scaling. When you create an auto scaling group, you can specify the minimum, maximum, and desired number of instances. Auto scaling group uses a launch configuration or template to launch EC2 instances. You need to define scaling options for your EC2 instances. You can scale instances manually, schedule scaling for a fixed time, or set dynamic scaling with a scaling policy based on the CPU utilization, network, and HTTP requests. You can put an auto scaling group behind an elastic load balancer. ELB will automatically send traffic to the newly added instances. It's common to use auto scaling with ELB for high availability. There is no additional cost for auto scaling. You only pay for the AWS resources needed to run your applications, such as additional EC2 instances added by auto scaling, and CloudWatch monitoring fees. Here's how EC2 auto scaling works with ELB. You've created an auto scaling group using dynamic scaling, with a scaling policy of a minimum of 1 instance, and a maximum of 3 instances. The auto scaling group is behind an application load balancer. There is 1 instance running to serve your application traffic. When you have more users sending requests, auto scaling detects the increasing traffic and launches a new instance. Once a new instance is up and running, ELB sends traffic to the new instance. Auto scaling launches additional instances, based on the incoming traffic, until reaching the maximum number of instances defined in the auto scaling group. Once the auto scaling group has reached the maximum number of instances, it won't add any new instance, even if there are more incoming traffic. If an instance fails, it will be removed from the auto scaling group. ELB will stop sending traffic to the failed instance. A new instance will be added to the auto scaling group. Once it's up and running, ELB will send traffic to the new instance. When the traffic decreases, auto scaling will remove underutilized instances until there is only 1 instance left, which is the minimum number of instances you specified. Auto scaling and ELB work together to provide highly available and responsive traffic handling for your applications, and make sure you have the right amount of resources up and running. In this episode, we've learned elastic load balancing and EC2 auto scaling. ELB can automatically distribute traffic to EC2 instances across multiple availability zones. There are 3 types of ELBs: application load balancer, network load balancer, and classic load balancer, which is the previous generation. ELB has built-in high availability features, and can help avoid the single point of failure. EC2 auto scaling automatically adds or remove instances based on the scaling policy you define. You need to create a launch configuration or template, an auto scaling group, and specify scaling options such as manual scaling, scheduled scaling, or dynamic scaling. You can also use auto scaling with ELB to provide high availability. Okay, that's all for ELB and EC2 auto scaling. Thanks for watching and see you in the next episode.
Hope you've enjoyed watching this episode. If you liked the video, please help us and hit the like button. If you want to watch more tutorials, please subscribe to the Cloudemy TV channel. Make sure to turn on the notification and stay tuned. At Cloudemy, we're passionate about cloud and AI technology. Please share your feedback and thoughts in the comments below. Feel free to let us know what topics you'd like to watch. Happy watching and happy learning.